So welcome back. We'll start our network SSR. So we have 4 speakers along with me. So what I do, I'll ask Mariki to come first for her presentation on discovering abuse via geographic disconnects. Mariki?
Hello again. So this is the second talk of the day that I'll be giving. And primarily what I'm going to talk about is the following. Passive DNS use and how people normally use it. When passive DNS may not work well, understanding WHOIS and GeoIP. I'm sure many of you are actually somewhat familiar, but I just want to set a level set. Looking at the differences between the GTLDs and ccTLDs and putting it all together to try and look at how do we, as best as possible, use all this information to get as accurate information as possible to look at malware campaigns. So I have a question for the room. How many of you are familiar with passive DNS? Okay, not all of you, not many of you. So I took out the actual slide that shows how it works. I gave that in my previous talk. So I'll just kind of mime it. So I think most of us understand DNS, right? Pretend this is my cell phone. I'm trying to get to, shopping at Sri Lanka, right? And so what happens is that, once I get a website, I try to go there, and then that query goes from my phone to the recursive DNS resolver. If the recursive DNS resolver doesn't have that information in its cache, it's a cache miss, it then starts the normal iterative DNS process of finding out who the authoritative server is, right? And so once it gets the answer, it puts it in its cache, the DNS recursive resolver, and then if somebody else Googles that same site, it goes to the DNS recursive resolver, it has it in the cache, and then it gets the answer. Right, so that's how DNS works. With passive DNS, what we do is there's sensors, they run within the recursive DNS servers, and the cache misses, so the queries that go to the authoritative servers and the responses get then sent over to whoever is keeping track of this passive DNS. We at Farsight have such a system, and then we create a database out of that. And so that database is the passive DNS database. And that's primarily what I'll be talking about, the information that's in there. There's other companies also that have similar solutions. We have data back from 2010. Okay, but that's what we talk about with passive DNS. And passive DNS, it was first described in 2004 by Florian Weimer in a closed security forum. And in the security industry, it's become a really valuable tool to figure out malware and botnet campaigns. And as you have more and more domain-generating algorithms, where there's literally hundreds and thousands of domains generated that are very short-lived, either for an hour or for a day, just specifically for malware, spam, phishing campaigns, right? DNS is becoming more and more important to really understand what's going on. So a little short introduction on passive DNS. So how the passive DNS typically works is that you start with a known observed bad data point. So it's either a domain name that you know is part of a malware or phishing campaign, a name server that you know that is hosting malware domains, or an IP address or CIDR block that's known to be part of some kind of malware. And so what you then do is you use that one data point and you do various searches in the passive DNS database to then find other IPs or domain names that share the same resources. Because again, you're trying to find that whole malware campaign so that typically you can end up doing some kind of a law enforcement takedown. And most of these campaigns are global, right? So it takes quite a bit of effort and quite a bit of research to really find out who all is part of this. So typically, right, in the past, really you're looking at a single point of commonality. So is it the same IP address? Is it the same name server? Is the same domain used over time? because it's been very interesting to find that some of these criminals are actually somewhat lazy, or they just get away with it, and they just, they use a domain, then they shut it down, then a month or 3 months later, they use the same domain for, the campaigns. So, you want to keep track of this. And so each relies on a single attribute that's exactly matched. So passive DNS by itself works really, really well when you have many related domains that coexist on a single IP or CIDR block, and you don't have a lot of innocent third-party victims. So it's basically, in most of the environments that we've seen, if you have a domain that's known to be part of malware, and you find out the authoritative server for that domain, if you then see what other domains that authoritative server hosts, more often than not, all of those domains are part of different malware campaigns. So that's the situation that we're in today. I'm sure that's going to change because the criminals are getting more and more clever, right, and they want to stay under the radar. And so if they have 1 or 2 legitimate domains that are hosted by the name server, right, then it's really hard to take that name server down. So we really have to be careful about that. So for those of you that have never seen a passive DNS database, this is an example of the searches that you can do. This is just using a UI interface. We also have an API, as do many others. So just so you can automate and create scripts, because let me tell you, typing this in one by one is not going to work. So in this particular case, I'm just looking up the different RR sets for APNIC.org. And what you see here, there's a screen, that basically things haven't changed. It's fairly stable. Right? So here we see that there's consistent NS records. They really haven't changed much from 2010 to 2016. Right? If there was a lot of variations, then you'd be going, well, why are there variations? Right? Why is the authoritative server changing so much? I did another query where I'm just looking at a specific, the Cumin APNIC.net, and again, you see that the A record also very stable. Right? So this is easy. I mean, if you saw a lot of variations, typically in the last, I don't know, 5 years or so, there have been occasionally a lot of registrar hacks. I don't know if you've seen this in Sri Lanka. I know that, in Pakistan with Google has been hit in a lot of different countries, so have others, where, somebody wants to take over their domain name and impersonate them. So when you see that the authoritative server is changing, right, that's already a clue as to, is that something that the company is doing internally, or is this somebody that has hacked a registrar and is trying to impersonate that company? So there are cases, however, when passive DNS by itself doesn't just work. And it's really, really difficult when you have no interrelated domains. Right? Everything looks unique, and you have way too many related resources. And so you have to start being more clever in terms of tying together the pieces of the puzzle. So the lone wolf scenario, it's very much an American term, is when the cyber criminal reuses nothing across sites. So every IP address used to send spam or host content is totally unrelated to any other IPs. And every domain name is registered using different name servers, different names, and also different payment details. Right? Just everything seems like it's totally different. So how do you then piece all the pieces together? So just for the fun of it, because I just gave an IPv6 security talk, and I'm always interested in what's going on with IPv6 related malware, I took a look last night at Spam House, what they have as a drop list for IPv6. I did a couple of queries on these, and it looks like some of them are related to RIPE address probes, right? That's not spamware. So, once I have time, I'll just kind of look at, why would those be listed. But I did pick out one address, and I just kind of wanted to see what I get back. So just randomly, I picked this last 36 from the list prior. And so I got 54 different resource records. Just kind of looked through them and wondered, do any of them look kind of funky? If you have a lot of bizarre strings, right, where it doesn't create any words in any language, and they're, maybe 20 characters long or so, that's a pretty good indication that it's a domain generating algorithm, right? And those are more often than not malicious. But here, I don't know, you just kind of take a look at it. This looked weird to me, right? The DNS seed masternode.io, darkhorn.ga, all that. So as people start looking at this data, and there are folks in my colleagues who have looked at DNS data for like 5 years, and they can look at it and go, yep, that's bad. I'm not there yet. But it's kind of interesting just looking at this data and then looking at, well, would some of this be bad or not, right? Would it be malicious? But as you can see, it doesn't make sense, right? Because it really doesn't have a lot of correlation, right? The v6 addresses, while they all come from the same /36, there's a lot of variety here, especially for all the different domain names. And the domain names don't really have similar characteristics either. So what you're trying to do as you're trying to figure out these campaigns is you want to look for other characteristics that may not be obfuscated and try and figure out what is really going on. So one thing is you want to see if a name server services a large number of domains, it may not be a useful attribute to try to follow, but look at the IP addresses of the bad domain is hosted on. And another thing also is if a domain is actively engaged in a lot of phishing campaigns, it might also be using some privacy or proxy settings. And so you really want to take a look at what's going on there. So typically what people are doing nowadays is they're augmenting usage of just typical passive DNS and looking at using WHOIS data and also GeoIP data to kind of try to get a better idea of, is this a valid domain or is this, looking like it's part of some kind of malware, and how to actually find out how to attribute that to a specific server or a specific entity. So I would imagine that most of us are familiar with WHOIS in some way, shape, or form. Basically, when you create a new domain name, right, you enter in the domain you want to register, and you provide some kind of information about point of contact. I say supposedly accurate because we all know that WHOIS data cannot be 100% relied upon. And I will stress the point that when you're using WHOIS data or when you're using GeoIP location, right, it's always about trust but verify. It's not all inaccurate and it's not all accurate. So there are times that it can be useful, but you want to have checks and balances to see, where you get accurate information and where things look a little bit dodgy. So if we're looking at specifically WHOIS, typically you can get some kind of a clue as to who the real registrant is. And I know from the law enforcement environment, right, it's always like putting together a piece of the puzzle because some data may not be accurate, but then there's one little piece of data that actually leads you to, who that actual real person is. So the thing to understand is that the name in WHOIS, you don't know if it's real or not, right? It could just be made up. The street address, right? Take a look at whether or not it's actually a mail drop or is it an actual physical address, although that may not even mean that it's part of the real person, or the street address is not part of the entity who presumably owns this domain. Same with phone numbers and email addresses. Right? I mean, you have the information, the WHOIS. I know that ICANN and other entities are looking at making the WHOIS much more reliable and trustworthy. We're not there yet, but it's not untrustworthy either. Right? And so I know it sounds kind of funny, but this is why you want the checks and balances. And also, it's kind of interesting, but in many, many countries, you may have the ability to get a court order, right? I mean, if there's criminal activity going on, then you may be able to get the credit card number that actually was used to pay for a specific domain, or also the IP address from which they placed the order. So privacy and proxy services, they're needed, okay? I mean, there's absolutely situations where you want to be anonymous. I mean, sometimes it's due to the human rights or, you know, life and death, depending on how and what you're using the domain for, but also it's very much used by criminals. So the privacy and the proxy privacy services allow the registrant to conceal their contact details from public display. And the one thing to point out is that even if used, law enforcement can at times get court orders to actually be able to identify who the actual registrant is. But it all depends on where you are, in which countries, and what laws they've instituted. Some proxy privacy service providers may also have a TOS in place, which allows them to unilaterally remove protections for a domain. And so again, this is depending on your geographic region and depending on how much proof you have that this is actually part of illegal, illegitimate activity. Oops. So I was looking at the APRICOT talks from 2016 because there was a session and a discussion for the APNIC region about GeoIP location data. And, you know, you can't 100% trust it. That is absolutely true, and I'll show you why not in a couple of slides. But what was fascinating, I was sitting in the hotel room last night here, and I just looked at www.ip2location.com, and by default, right, it looked at my IP address and gave me this screen. And I'm like, okay, it knows I'm in Sri Lanka, it knows I'm at the Hilton, right, and it gets its domain name from Lanka.com. So this is all accurate, right? So that's why I'm saying, like, you can't 100% trust it, but it doesn't mean all the data is inaccurate. And I did the same thing with MaxMind, by the way, but they don't do it automatically. You have to enter the IP address, and it said the same thing, right? So it was a good use case where, wow, look, you know, this is pretty easy. I have an IP address, I want to see where it is, and I get the information and the location that is accurate. But let me be clear, there's a lot of imprecision in GeoIP location data. And what is really a problem is if you place blind trust in it. Do not place blind trust in any data. Always have some kind of checks and balances. Trust but verify. I always use that expression. And if you get the wrong data, it can really be detrimental to some poor person who's quite innocent, but, you know, is incorrectly identified as a spammer, fraudster, you know, will have problems with the police and who knows what. And the pointer that I'm pointing to, you know, from the second bullet item here, is actually a study that was done by somebody last year as to, you know, a comparison of GeoIP location data services and comparisons and, you know, how bad they really are. Basically, the fact that you can't just have blind trust in them. And it was also really interesting, I think it was last year, I can't remember now, it was within the last year. There was a story about some poor farm in the US, in Kansas, right, who MaxMind, they decided to round off some numbers from the longitude and latitude, and it unfortunately placed the location at the front steps of this farm. And so a lot of fraudulent activity, criminal activity, was blamed on this poor farm. And they actually sued MaxMind because it caused them a lot of problems, a lot of issues. So it was interesting when you look at the MaxMind website, and I don't know if this happened because of that issue. My guess would be yes, but it now actually, in the front first page of their website states that IP geolocation is inherently imprecise. Locations are often near the center of the population. Any location provided by a GeoIP database should not be used to identify a particular address or household, right? Because again, for liability, that's why they would have that statement in there. So it's kind of interesting to me. The one thing to really look at with any GeoIP location service that you're looking at potentially utilizing is how's the data collected and how are updates done. So mobile and cellular networks, right, as you're moving around, you get a different IP address on your phone. That's not really utilized by a lot of GeoIP location databases. And also the RIR IP address block transfers. And in that APNIC session that I saw at APRICOT, there was a woman from CNNIC that actually had made a comment that they have a lot of different databases and a lot, they're trying to build a database and they're trying to figure out what to do with it, right? But it's all about creating more accuracy because GeoIP location could be useful. Of course, there's that other side of it where you don't want to do GeoIP blocking for any kind of content. But that's irrelevant to what I'm trying to do, right? I'm trying to help with actual attribution of finding, where you have criminal activity. So the geographical attributes that are interesting in WHOIS is, the country attribute. So where's the entity located that's actually the registrant for the resources? And then also the latitude or longitude where the block is used. So APNIC actually records the economy where the organization is registered, so what country. But as I found out as I was looking at the review, because I don't know how all the RIRs work, I just figured I'd figure out what APNIC does, so I can relay that information for those of you that weren't at the APRICOT meeting. But the members can also register customer assignments to indicate location where a network is deployed. There's no enforcement of the convention or checks on correctness, and they're working with the members to identify the needs and the RIR's role. So that's ongoing, which I think is a really, really good thing, right? So it's all work in progress. Another thing I want to bring forth is the difference between the country code top-level domains and the global top-level domains. So there's a difference that has to be understood where ICANN administers the global top-level domains, such as the .com, .net, .org, and the, 50 to 100 new ones that you have, .music, .love, I don't know what they all are. ICANN requires the WHOIS service, although they do permit the privacy and proxy registrations. That is not necessarily true for the country code TLDs. So they are run according to their own rules. Okay? They're not ICANN rules. The rules that the ccTLDs decided that they're all going to adhere to. And some of them have policies which limit public access to the WHOIS data for any or all of the domains. Right? So that has to be understood. So for the ccTLDs, the WHOIS information may only be available via web form and maybe only to the person that registered their domain or the people that are part of the company. And some WHOIS information may be displayed in graphical format so that people can't do any web crawling. And sometimes the WHOIS information doesn't even exist. So just understand that difference between the GTLD information and the ccTLD information in WHOIS for the domain names. So I'm going to show you another example, just looking at how you would tie together the information that you get from WHOIS, from GeoIP location services, and also passive DNS, and trying to figure out the pieces of the puzzle. And now remember, I'm just showing you, one at a time queries. You would never really do that in reality unless you're trying to get familiar with it, right? You would be using API and scripting to this. So there's a feed that we have which is newly observed domain names. right? And it's only for 5 minutes, 10 minutes, 24 hours. In August, I was trying to see whether or not I could find anything that might be scamming the Olympics, right? It was the time of the Olympics. So looking at this newly observed domain feed, while I was looking at that, is because if it's newly observed, which means it's the first time that we've ever seen it, the first time that our sensor has ever had a cache miss for this particular domain, it doesn't necessarily have a reputation score yet, right? So for 24 hours, right, I want to see, you know, is this good or is this bad? And so randomly, you know, I just picked olympicgames.club. Like, I don't know, looks, you know. So there's a couple of different WHOIS databases, Domain Tools or Cyber Tool Belt or two. This takes the information from a company called Cyber Tool Belt. And so what I see here is I see that the WHOIS record was created actually in August, right, of 2016 and expires a year later. And I see that the WHOIS contact is actually somebody in India, right? That doesn't mean it's malicious, right? It's just that somebody decided that, okay, I'm going to create this, and the registrar, you know, used GoDaddy, right? Anybody can use that registrar. And so I also wanted to see, you know, the actual IP address and what do I see on that, right? So using GeoIP location, and, you know, sure enough, it shows me that the owner is, you know, in GoDaddy, and they're based in Scottsdale, Arizona, which is true. And so I was then curious in terms of what data do I get from passive DNS? So I put that same IPv4/32 to kind of get the R data for it, and I see that I have 1,186 resource records. So I'm just taking, you know, a snapshot here. So if you look at it, you know, they're all over the place, right? Argentina, Australia, Belgium. I just took a snapshot. I don't have all 1,000 listed here. And then what was interesting to me is using the .xyz new top-level domain. Even the folks that are actually running that registry, right, they have admitted that, you know, a lot of their domains are used for abuse activity. And they're actually, but they're very good. I mean, I had a conversation with them, and they're aware of this, and they're working really hard to actually mitigate and do the right thing and work with law enforcement and all that. So, you know, I'm not going to bash them for that. But if I see a domain that has a .xyz as a ccTLD, I get suspicious. Right? So again, like, we can go further, I mean, and looking and digging and figuring out the clues. But the main point that I want to have as a takeaway is that passive DNS in and of itself is probably not good enough, right, to really get the entire data set. What you do want to do is you want to augment it with WHOIS, and at times also with GeoIP location data, because it'll give you a much better set of data points, because I do think that the criminal activity is getting smarter, right? And they're trying to fly below the radar. And so they're not going to keep on just using the same authoritative server for all of their malware domains. They're going to stick some good domains in there, right? Because it'll make it much harder to do takedowns. So combining these tools will give you a much better feel for what's real and what's not. And can't emphasize this enough, don't place blind trust in any data. Have your checks and balances. And as passive DNS grows in use and popularity, users find new ways to use the data. Malicious users will obfuscate their digital tracks. I mean, that's what I would do, right? I mean, anybody that's you know, breaking into a place, you know, they want to make sure that nobody recognizes it's them. I mean, first thing you do when you break into a device, right, you wipe out the logs. And you also want to work around techniques that do obfuscation. So you want to augment passive DNS with new existing data, such as WHOIS or GeoIP location. And that's it. Do I have time for questions? Thank you. Oh, one question?
Rajesh Jain, is it being used at some places? How much is the usage of this passive DNS? Or is it under development? Or
Oh,
could you
no,
please-
it's been used extensively. Yeah, so this passive DNS database that I'm talking about, it has data from 2010. Yeah, and it's been used extensively for at least 4 years, 4 or 5 years. So universities have used the data for some research studies for specific campaigns. And certainly many companies have used it to figure out malware campaigns.
And if I may ask, in South Asia region, for example, India, Sri Lanka,
I don't think so. Yeah, I was at SANOG in January, and I started to talk to people in the South Asian community. But if anybody's interested in talking to me about it, you know, I would be more than welcome to.
thank you.
Yeah, thank you.
Thank you very much, Marike. Extremely sorry for my delay. Thank you very much, Fakul, for starting the session until I come. So our next speaker is Fakul Alams, and he will speak on securing the global routing system and the approach of the operators. Fakul?
Thanks, Ronan. Thank you, everyone. So my name is Fakul. I am from APNIC training team. So one of my major job is to provide training to our members. And while doing that, the training we provide mostly on the technology related to the RIR. So yeah, DNS, IRM, IPv6, all the stuff. So when we talk about the members and discuss about those new technologies, we receive a lot of feedbacks, and kind of we ask them or teach them what are the best practices, what should they do, and then later we get a feedback from them, and this talk is kind of matching these two things and see what basically operators are doing. So I think the whole slide, this is the most important slides, because I have my email address here. So feel free to drop me an email if you have any query. So while we discuss the security, I think routing security is one of the biggest discussion, because prefix hijacking, AS hijacking, these things are pretty common, and there are a lot of motivation behind it. So I'll go through these in the first half and discuss what are the issues, what are the solutions we could have in place to make our routing system more resilient and secure, and see how we are doing it, especially in this South Asia. I'll try to compare some data and see what basically operators are doing, right? So I did this presentation a couple of times in other NOGs. I used to use the screenshots of the incidents, but somehow audience are not happy, because there are few operators from the incidents, they came and say, why you have my names in the slides? They feel embarrassed. So I just have Google, use it, just do a quick search, prefix hijack in South Asia or Asia. It will give you the whole list. I don't want to embarrass anyone in my presentation. And do an advanced one, just minus Wikipedia, that I don't want Wikipedia in my Google search. Let's do it, and you have all the list and all the history, who is doing all those things, right? And the motivation behind is, not the motivation, the most of the incidents are basically for the fat fingers, we call it, like they do a typo, they mistype their AS number, all the prefixes, and upstream is not filtering anything, and it goes propagated. So with a positive intention, I say 99% of those biggest incidents are mistake, it's not intentional. But we also see other motivations, especially spamming. So if I could hijack your prefix, announce it, spam for half an hour or 1 hour, and that's it. So you have a bad reputation in a spam house and other sites. And sometimes they do it for some other reasons. So there might be country-related tension in between. So they do hijack one another prefixes. And regardless of how many firewall IPS and IDS you put, If I can get your prefixes and the traffic, as long as these are not encrypted, good luck. So the current practices we have right now is kind of this. So if you are an operator, like a transit or an ISP, you have an understanding what does it means. So if you are my customer, you connect with me and say, hey, this is my AS number, this is my prefix, could you please allow me to have a transit, right? So as a transit, what I do a LOA check. We called it legitimacy of address. So I do some query, I do the data checks and see whether you actually own those prefixes or AS or not. If everything is good, then I put a associated prefix filter, AS filter, and other things, all the combination of both to do the filtering. And it's kind of a cycle, right? Then you have a new customer or the existing customer say, I have a new prefix, could you please announce it or not? So we do the whole LOA check and create all those associated prefix and AS filter. And to do that, we could have a LOA check manually. So we do a WHOIS query to any IRR database or RADB, and there are other independent database, and manually check what is the route object, TXC, admin C, and if it is a match, then we allow those things. So that's why I think it's very, very important to update the WHOIS, right? You got the point, right? So you update your WHOIS, and if it doesn't match, if you don't have any associated route object, your transit not supposed to allow those prefixes, right? You could do it in automation. We called it RPSL, routing policy specification language. So you automate the whole process using RPSL object and push all those configuration to the router. So you don't have to do all those manual checks. Along with these RPSL, we have RPKI, resource public infrastructure. So what I mean by resource is your AS number and prefix. So you cryptographically sign your prefix and the AS number and say that, okay, this prefix will be announced by this AS number, and you signed it and you create a ROA. And all the cache validator, all the other operators, they can do the verification cryptographically with a public key, private key infrastructure and say that whether it's verified or not. So this kind of two-way is not a RPK is replacing RPSL or RPSL is replacing RPK. It's kind of a lot of discussion whether we could have RPK and RPSL in parallel. So how we do it? So the LOA check and the WHOIS is kind of as a complex job, right? You have to, those who have experience, you have to log into RADB or some other places, you create the objects. And very often I saw that people add proxy object. So what it means that I don't have any access in RADB, but I request my upstream to create a proxy object on behalf of me, and they create it and it's there. You don't have any access to that object, and later if you want to add your own object, you don't have any clue. So this is a screenshot. It says that is a proxy registered route object in RADB. I mailed them, I talked with them, but there is no response because you don't have any actual way to remove all those proxy objects as long as the actual owner report to the report RADB and remove all those things, because sometimes for operators it's been complex how to add all those route objects. For others, implementing RPSL, adding all those information is in WHOIS database is kind of is not, the thing is not secured, or the thing is there might be a business computation. There's kind of an example of AS12999. So if you do a WHOIS query, you see the whole list of their customer, and looking at these import and export, I understand how they prioritize their announcement. So if I am a customer or transit of them, I know which local preference are using for which customer. And looking at that, I can see who are their customers. And it's like whole line of, kind of a 5,000 line of WHOIS information. You just do an WHOIS, WC minus LC is a big chunk of WHOIS information. And for some operators, they don't feel comfortable adding all those information in public WHOIS database. with RPKI, the issue or the solution, we could have hosted CA or delegated CA. So that means you host your key in RIR servers. Some people who are paranoid, they said, why I put my private key in some other servers. So they could go with the delegated array, but the problem is you have to configure your own CA implementation. It's a bit complex. Maintaining a CA is not an easy task. And when you have all those ROA, at least when you do the validation, you need your ASBR router or border gateway router code to support RPKI, and otherwise you can't do the validation and other things. So, and the way we are going on, if I say there's a learning curve all the way. So we talk to our member, we tell them, okay, like in 10 years back, RPSL would do it. After a couple of years, we say, okay, we have IPv6, we have do RPSL NG, that's also good. And for 5 years, we're saying RPKI. So our members might say, why? Every couple of years back, you are coming up with new technologies and asking us to implement it. Why we do it? What's the benefit out of it, right? Why not we have something very, 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 very good that we should implement once in a while? So let's see how the operators are basically doing in terms of RPSL and RPKI. So this screenshot, I got it from a tool called OpenBMP, BGP Monitoring Protocol. So you feed all those BGP information and all the statistics. If you look at this graph, you see that 63% of those route we have doesn't have any RPKI or RIR objects. But if you look at the RFCs, it says you should have route object at least to announce those prefixes to the global routing table. So what it means that 36% of those prefixes, they could create, without creating any route object, they could announce it to the global internet table. So why should I create it? Why should I go with all those complexities, having a proxy object or route object, right? And we have 63% of data who has a route object, but among them, roughly 20% of them are violation. So what it means that it doesn't match with the actual information. So you create a route object, but you are doing something else. You are announcing with some other prefixes. So these are the example, and we used to see 2-byte public private address AS number in the global routing table, but is 32-bit address is also there. So someone is actually creating a route object based on a private AS number which should not be visible in the global routing table. They're creating a route object for it, and they are announcing it into the global routing table. Sometimes people say it's a mistake, but if you are doing a mistake, why you are creating a route object in the routing RADB with a private AS number, right? You don't need it. And those prefixes we have with RPKI looks like 13% of them are violated. Most of the cases is invalid prefix mismatch. That means you create ROA for /19, that this prefix, this AS number will announce this /19, but when you announce, you announce a small prefix as /24. So it says that you have the same AS, but prefix doesn't match. I mean, the AS length doesn't match. So you should create ROA for /24, /23, or those prefixes which you announce. We also see invalid origin. That means you create a ROA for AS 14080. 8309, but you are announcing it from some other AS number. And this is one of the example is from Nepal. So this prefix /19 202.70.64.0/19 owned by Nepal Telecom. They create a ROA for it, but this prefix, one of these /24 from this /19 202.70.91.0 announced by AS 58456. That means Nepal Telecom delegate or allocate these prefixes to his customer, but they create a ROA for them, not for the customer. So it says that it is originated from an invalid AS number, right? So let's look at a few of the statistics, how we are doing in South Asia in terms of RPKI implementation. So so in whole, that's how it looks like. This data is from RIPE and CC. So all the 8 countries, Afghanistan, Bangladesh, Bhutan, India, Maldives, Nepal, Pakistan, and Sri Lanka. If you look at these, so I have, the first column is, says how many IPv4 prefix are covered and how many of them are valid. So if you see Bangladesh, there are like 24.24% of those prefixes have ROA, 23.26% is valid. So there we see like 1% invalid ROA. Bhutan is absolutely fine because I think Tasisel and BT is doing absolutely okay. India, I did this presentation in Sanok, that time it was 0.1%, but I see a kind of increased jump, 0.39%. Maldives, nothing out there. Nepal, most of the cases, all those invalid ROAs are invalid AS match, length match. So that means they create ROA for whole /19 or 16, but they're announcing /24. Then Pakistan and Sri Lanka. So then the other slides I will show you now is in zoom in each country and see Afghanistan. The day I took all those data is I see 46 AS, 270 IPv4 prefix, 3 IPv6, no ROA for IPv4 and IPv6. Bangladesh, 402 AS, roughly 3,500 IPv4, 60 IPv6. 55% IPv6 has a valid ROA, and we have some invalid ROAs also. Bhutan, IPv6, 3 v6 prefixes, 3 ROA, absolutely correct. And there is no invalid ROA from Bhutan. So they have like a very good coverage of 86% of ROA in IPv4. India, very less deployment, I think is 0.3%, nothing in IPv4. Nepal, 60 AS number, 475 IPv4 route, 12 IPv6 route, lot of invalid ROA. The only reason is they create, so when you create a ROA, you have the option to define the AS number, prefix, and a max length. So most of the cases they have, if they have the prefix like 202.496.0/19, they set a max length to /19. So create a ROA for 19, but they are announcing /24/23. So I think it's one of the biggest reasons they have like 35% of invalid ROA. It's pretty easy to correct. You just log in, create a ROA for /24 or whatever you are announcing. Pakistan, they have 11% of IPv4 and 8.8% on IPv6 prefixes which have valid ROA. Sri Lanka is pretty good. So I see like 42% IPv6, 42% of the IPv6s have a valid ROA, so there is no invalid in IPv6. Small chunk of 8.7% invalid, mostly the same reason, invalid length mismatch. So in summary, what we have seen is that we know what we should do. So we should create route object, we should have a ROA, but still is increasing, but we see the mistake or the issues we have is easy to recover. We could do it if we monitor and see what's going on, and is very easy to recover. And if you know and monitor details on BGP operation security, I'll forward to this draft RFC. So IETF OPSEC BGP security 07. Just do a quick Google search. It has the whole summary what you should do as an operator. How do I collect all those data? So the first one is the OpenBMP. It's still not finalized, it's in draft. But if you go and see, it's one of the best tool I've seen, that it dumps all your BGP data. You have the historical information, and you really see how many AS path has been changed on your prefixes and on all those stuff. So it's open source. You can get it from the GitHub. For the RPK, I use RIPE and CC RPK statistics tools. So I call up so I got it from the GitHub, have my own tools, call up the API and get all those information. And for the cache validator, you can use also the RPKI RIPE and CC cache validator API to do the verification. I hope that's all from my side. So if you have any query, I'll take it. I'm here for today, and yeah, I have a question. Sure.
Hi, Aftab Siddiqui in Telugu Networks. Initially, you mentioned that you're not going to mention the ISPs or the operators who are announcing bad routes. Let me help you. I'm just going to specify South Asia only because we are in the South Asian region. So from the ascending order, India is announcing 14 bogus prefixes. Bangladesh is announcing 10 bogus prefixes. Pakistan is 1. Sri Lanka is none. Thank you, Sri Lanka. That's it.
Thank you, Abdul. So that's one of the good part that they are announcing bogus. But my point is, I'm not sharing all those incidents they have done, all those countries and the operators, where they miss origin and hijack someone else prefixes. Yeah, that's it. Thank you.
Hi, Aaron Hughes. Just out of curiosity, do you have any real statistics for follow-up with your customer base that you're training on who's actually using validators? I mean, it seems interesting to me that you're training on how to create ROAs, but if you're seeing invalids, then they're probably not actually using any tools to decide whether or not something's valid or invalid. Do you have any feedback or data on that?
No. So we don't have any statistics on how many people are doing the validation, because I don't know how you do it, because it's very hard who is validating or not. It's a good point, because last couple of years from APNIC, we are saying that ready for ROA, create the ROA, to kind of encourage people, at least create ROA. If you don't have any ROA, how do you validate it? From this year, we're trying to encourage our members to at least validate the prefixes. And most of the cases in this region, what I see, they have dependencies on the router, because they have old firmware, most of the cases, which is not supporting our PKI cache validation. But in short, yeah, I don't have any statistics of how many people are doing the validation.
And are you giving any training with tools to look at what's valid and what's not once you leave the training, or?
Yeah. So in our training, we have a tutorial where we show them how to create ROA and how to place a cache validator. So for our case, we use a RIPE NCC cache validator and actually show them how to configure the router actually. So I did a talk in Sanog in Mumbai, and half-day tutorial on how you configure and do the validation both in Cisco and Juniper.
Thank you.
I'm Rajesh Jain from India. I was very curious to see that some mentioned that 10 rogue announcements from these things. I will be very happy as ISP Association of India if it comes to our knowledge to be able to make sure that we are able to request the persons or not to do this. Thank you. So we'll be happy to.
So do you answer it first? Or you have a yeah. So yeah, I think with the India you have your NIR, right? Own NIR. So I think having an NIR, you have a dependency of creating ROA, because every member doesn't have any APNIC. So as a NIR, I need to be ready to implement or have infrastructure to support ROA. Otherwise, for an Indian AS, which is member of ARIN, they need to wait for ARIN to get ready to have ROA, RPK support.
Yes, ARIN is making steps to rectify this. Thank you.
Yeah, Aftab Siddiqui in Telugu Networks again. Just to clarify how I got this information, I got the information from the CIDR report, which is generated every week. And if you are on APOP's mailing list or NANOG mailing list or several other mailing lists, then you should get that email every week. So just find your own AS or just search for your country initials. You should find if you are announcing or any of your fellow peers announcing any bad routes. So it would be easier to find out. Thank you.
Yeah, thank you. So you can subscribe it easily. I think it's a free email every week. And there's a misconception in the vendors and the operators. They sometimes call it Hall of Fame, but it's basically Hall of Shame. So if you have your name in the list, it's shame, it's not fame, right? So yeah. Any other question? No? Thank you.
Thank you very much, Fakrul. So our next speaker is Aftab Siddiqui. He'll be talking on open networking revolution. So Aftab.
the slides, please? Thank you. Well, you all must be aware of me now. I'm Aftab Siddiqui, Intelligo Networks, a usual suspect of making noise. So, I'll be talking about the open networking revolution. Revolution for me, I'm not sure it is for you or not. I was quite impressed by the new things happening in the networking world. It was quite new for me, and I would like to share with everyone. So it's just a brief overview of what open networking is. It's a couple of years back, a few big players in the market, Facebook on top of it, decided to start a project called Open Compute Project, and that's the definition I got from their website. And as part of the Open Compute Project, there are multiple sub-projects. And if you can see, there are storage, networking, server design, open rack, certification, hardware management, data center. Most of the projects are not progressing at a very good rate, but networking is something which is progressing on daily basis. I follow their presentation, I follow their meetings every month, and it's something new is happening every month. So that's what it is. It's this is, if you look at the traditional networking, this is how it is. You'll get some additional features from every vendor, proprietary network OS, proprietary system, the whole architecture of that, and definitely a proprietary silicon. Mostly, not all the time, but mostly proprietary silicon. Either it is Cisco, Juniper, or any other vendor. So what open networking did, they said, okay, we have been using disintegrated hardware in the server world. Let's do this in the network world as well. So this is what they did. They removed the all the layers, and they said everybody will do their own job. Operating system is disintegrated from the hardware. Open standard hardware was discussed, and they came up with a standard, and they used the merchant silicon. Initially, it was only Broadcom chipset, and now there is another player called Spectrum. It is from the Mellanox family. So what are the choices? Frankly speaking, 2 years back, I had no idea about all these switches and hardware that you can use. But after getting used to it, we have already deployed a lot of switch, and wherever I go, I see a lot of such switches in every data center all around, at least in Asia. I'm not sure about US and Europe market, but this is happening in Asia. So these are the vendors. I'm not connected to any of them, so I don't care which one you buy. So it's totally up to you. But if you look at the most important thing, the port density is almost same. Their ASICs are almost same, and CPU, they're just randomly selecting it on the basis of what, I have no idea again. Memory is probably whatever cheapest available, they're just using it. These are the switches. It looks absolutely like a switch, nothing different. Look and feel just like a switch. Yeah, better than, the best thing is you can just mount them on a server rail rather than a switch mounting kit. Well, they were all inspired by Facebook, as I initially said, and this is what Facebook is using. One of the best thing is this is openly available. The architecture is openly available, not the switch. You cannot buy the switch from the market, but the architecture is available. You can download all the details, what are the specs, how they work, and the OS they are using is FBOSS. I was just talking to Matt a moment ago just to find out how it works and how it is, and then we just Googled it and found out that this is just Linux. So what was the whole intention for me looking into this thing? So before jumping onto that, let me explain that we just discussed about the hardware. We just touched a little bit about the hardware. So you have to run a network operating system on top of it. So what are the options? The option list I initially said, there are many options. Cumulus Linux, PicOS, IP Infusion, Switch Lite, Microsoft Sonic, which is not actually a network operating system, but it's quite different. FBOSS, which you cannot use at the moment. But there are a lot of options available. So which one should I use? So what we took a different approach. The thing is, today, if you want to test some feature or some vendor-specific feature, what you do is you just install it in your switch or router or wherever it is possible. These days, you can just download the Cisco CSR 1000V or IOSR XV, or then for Junos, you can just download the Junos virtualized version as well for MX or for SRX as well. So this is what we did for network operating system of the open networking. We found out that only 2 players were providing the virtualized version which you can use on any VM. So that was Cumulus and APNIC42. All the other was not providing it. So either you have to buy from them and then install it on a hardware switch, or just buy a lab from them or virtualized environment from them and just test it, which is not feasible to start or play with. So that's why we used Cumulus and APNIC42. Again, I have nothing to do with both of them. It's up to you. So that was my first impression. It was pure Linux. There was no CLI. So when I installed it, this is the command prompt I got. And I was like, okay, now what to do? So, but then I went to their website. There were some tutorials available, and the command line for iOS, Junos, and Cumulus, that how you do it on iOS, how you do on Junos, and how you do on Cumulus. It was available. It took me a couple of days to work out how to configure a switch, because ultimately it's just a switch. What you do is you create a bridge, you create a SPI, and then that's it. And I was doing all this working for one customer, and the customer was in Australia. He was in Australia, and the target was pretty aggressive economically, and it was supposed to be as cheap as possible, and we were supposed to give them all the features as they were looking for. So they had all this requirement set, which I've just mentioned. And as I said, budget was challenging. That was the only constraint we looked into. That was the only constraint. That's why we looked into open networking. So that was our initial design. One thing, if you see in the middle, you will find a word called VTEP. So we used network virtualization overlay, that is VXLAN, because they already had a very big layer 2 infrastructure available, and they did just want to expand it. And there was no point to just redesign the whole infrastructure. We said, okay, whatever you have, you just use it. We will just put something on top of it, and we used VXLAN, and it worked very well. So, but the problem we had in this scenario, we were only using 4 POPs as the proof of concept. It worked very well for 4 POPs. But if you are talking about at least 120 POPs, which was their target, it doesn't scale that much. It doesn't scale very easily. You have to have some sort of automation. You have to have some sort of scaling capability in the network OS so that you can scale quite rapidly, and you should be able to provide all the services they are looking for. With Linux, it's not very easy, because all the network engineers are not familiar with Linux. So they are familiar with Cisco iOS, they are familiar with Junos, and they call it Cisco-like CLI of Arista or Brocade or any other. So they are not familiar with Linux. So you have to provide them an abstraction layer of automation. Well, this is how you do the configuration. This is how you do the troubleshooting. It was complex for their enterprise IT. So we came up with a solution of automation. We said, okay, fine, we'll just automate it as much we can so that there are no fat fingers, and there are very less chances of configuring something bad, and then you end up doing a troubleshooting. So we came up with the basic requirement that
what are the requirements you need, we have, and then we list down everything in an Ansible. We used Ansible as the automation tool. We list down everything from host name, number of ports, Cumulus or Linux, call it swap, SWP, switch ports, loopback, and bond interface. Bond interface is the LACP, link aggregation protocol. So we used all that. We gave them, this is the information you need in a script. So you just have to enter this information and just magic happens. And that was the standard configuration as well, because every switch configuration required user credentials, enable routing. We were using Quagga on that, NTP, DNS, MOTD, and the SOP interfaces, because it's not necessary to have 48 port 10 gig switches everywhere. They were using a mix of switches, somewhere 48, somewhere multi-rate for 32 100 gig switches. So we had to be sure that what configuration is required at which POP. So this is, as I said, we were using VXLAN. So we had to, because once the switch is deployed, we were supposed to make it simple for the customer, so they can just drop down, select the drop down menu and click few buttons, and it, again, as I said, magic happens and the configuration is done. So this is the actual configuration. We gave them, this is what is required, and then we asked them to provide the POP and the switch port and the speed, and they just did configuration and it was done. I can actually provide the whole Ansible playbooks. It was big enough, I couldn't fit it in the configuration in this presentation, so it's with me. If anybody is interested to look into it, I'm happy to share with you. So that was our very first deployment experience with the white box switching or the open networking, and it worked very well. But the thing is, it's not. After deploying it, so many people asked one thing. Oh, so is this SDN? So the answer is there is no way it is even close to SDN. So we don't do SDN. Well, I don't think so anybody is doing SDN. So it's not real. So we are not doing SDN. It's nothing to do with SDN. It's pure Linux networking, nothing else. Same switches, same hardware, and just a bit creative way of doing things. VXLAN can solve a lot of problems, but it creates few problems as well. It breaks the LLDP, and it breaks LACP. So if you are quite interested in LACP, sending it to the other end, then VXLAN is not for you. And same is, well, you don't use LLDP much, but sometimes this customer just complains that LLDP is not working. I'm not sure why they use it. But operationally, it's simple, it's economical. The switches are cheap, but they are not bad. Try it if you want to. And as I said, VXLAN just create a little bit complexity. So this is the packet captures from the VXLAN header. So if you look at it, it just make it complicated. It's just add 50 bytes of more header. And if you are using QNQ, just the bottom snippet is just more complicated. So, and on top of it, if you are using 802.1p, it's just make more difficult. So it is adding a bit of difficulty as well, but it is giving you simplicity if you are using automation, but it is economical and it scales very well. And we have done around 20 POPs so far in Australia, and the target is 120, and it's absolutely going brilliant. So that was my experience with the open networking, and I think people are going to use it in the future. And if you are interested, just let me know. I'll be able to share more information with you. Thank you. So, of course, if any questions.
How the support post installation would be available for, I mean, that is one question which, while it could be installed, operated, but patches and
Well, yes, very interesting. You don't have one throat to grab now. So you cannot have one simple support policy. So you have to have hardware support separately, then the network OS support separately. And if you are using an automation, then there is no support at all. You are on your own. So yes, it's difficult model. If you are looking for the support, it depends upon which network OS you are using. If you're using Cumulus or IP Infusion, they do have support structures. They are all new. So of course they are evolving. It will take some time. They are easy to just talk to. That's what I found so far. Backswitch, IP Infusion, Cumulus, all three of them. But yes, it's a challenge. Today it's a challenge because it's new. You won't find a lot of blogs or community forum filled with so many problems. So it is a challenge.
Thank you.
Hi, Aftab. Great work around all the automation stuff. Now, you clearly pointed out, rightly said, it's not SDN. But with all so much automation that you're trying to achieve, right? Why not SDN? Because then, if you're trying to do scalability and, if you want to introduce more vendors, it just makes your life a little more easy, don't you think?
Well, actually, SDN is solving the whole world of the problems of the world. And actually, I was not facing any problem with the SDN. So the point was, why you need SDN? You have to ask this question, why you need SDN and what is SDN? I had no intention to disintegrate the control plane from the data plane. The only intention we had just to disintegrate the network OS from the hardware. And we achieved in an economical manner. And automation has nothing to do with SDN. Automation you can do with Cisco or Juniper as well. If go back 10 years, TCL is available for I think more than 25, 30 years. And the thing is nobody was using it. Ansible or Puppet, it just make it simple to use it. It doesn't make them SDN or anything else. So I'm still not convinced to use SDN. I think SD-WAN is a product. SDN is not yet a product. So unless and until there's a product for SDN, I'm not convinced.
Yeah, I mean, as you rightly said, SD-WAN, of course, is a product, but then, it just doesn't sustain on itself. You need NFV to support it, right? But for your SDN, use cases, it's not typically a product that you can sell because it's more of an infrastructure, right? So unless you're selling infrastructure as a service, of course, you're not going to be selling something which is SDN based. So it's just to make life more simple around your infrastructure. Talking about, I know automation you can do without it, but I think you've got all the right pieces there, isn't it? You've got the white boxes, correct? You're doing a lot of automation, which is good. But then maybe, just give a thought about it, because SDN, there are many different implementations that you do. It's not just one way. Just look at probably what works for you, but probably it's just the next step. You could look at it. You've got all the right pieces in place for making a network SDN.
Well, I absolutely agree with that. So let's say we have taken a first step towards SDN, right? So eventually, never, we will do SDN in maybe 4 or 5 years. But the underlying infrastructure is there. The white box switches, as you said, they are there. If somebody come up with a product of SDN, then we will just rip off the network OS and install the SDN controller, and then the magic will happen on the controller. Let's see how it goes.
Okay. Thank you.
Yes.
Hi, Aftab. Anurag from Hurricane Electric. I have a dumb question here. It makes sense to use things like Ansible to have abstraction layer for deployment, and I think even in the traditional networking, it makes more sense to do deployments in that way. But how you manage troubleshooting? So people who are not used to work on Linux and say you pass a VXLAN and that's not working, or something else is broken,
Yes.
how you manage with the abstraction layer? Do you have Ansible playbooks for troubleshooting as well?
Absolutely not. So what we assumed, and we were hiding behind one idea that if you are not making a mistake, there is no need to troubleshoot, and that's it. So
Excellent.
It's a false assumption, but it is there. And that's the major problem with Linux networking, because what you are doing is a networking and asking the network engineers to use Linux for that, which is scary for them. It was scary for me as well 2 years back, because I was a Linux user, not a administrator or a DevOps person. So what we did for the enterprise engineers, because I learned a lot of things in last 2 years, and then we were trying to convince the enterprise engineer, which they were scared. So we wrote a lot of wrappers. So it was the shell scripts to just give them Cisco-like CLI troubleshooting skills. So how to find the MAC addresses, how to find if the port is up or not, how to find if you're learning ARP or not. So we wrote around 10, 20 shell scripts just to give them the same output they get from show MAC table or show ARP or something like that. And when I last presented in Apricot, and this is what I said there, and Cumulus CTO picked up that presentation, and I got a call from them, and they said, we like the idea, and we want to share that we are working on an actual wrapper for all the Cisco-like CLI for the troubleshooting. So, well, that's Cumulus only. If you are, and they are paid. So if you don't want to do a Cumulus license or Cumulus OS, if you want to use Open Network Linux, then you have to come up with your own. So yeah, it's a challenge.
Thank you.
Okay, thank you everyone.
Thank you very much, Aftab. The final speaker, last speaker for this session is Matt Jensen. I think Facebook is very popular in this region. So I will talk on Facebook is scalable interconnection.
Hey, it looks like I got about 6 minutes left, so I'll try to keep that short, though I don't think I can do it in 6 minutes. Let's see. So, yeah, what's our mission? Well, to make the world more open and connected. My part in that is scaling our network connectivity to enable that. So, what makes the world more open and connected? The ability for you to share stuff. And that has evolved a lot over time. I mean, if you look at the timeline from a couple of years ago, that was basically all text. That started to integrate a few images, becoming more and more images, and in the end, it's mainly images and a lot less text. And we only started actually doing video on the platform 2 years ago, 2014. So this is actually fairly recent. That was just when the whole Ice Bucket Challenge stuff started happening. So it already went pretty popular back then. And now if you look at like the whole Chewbacca lady thing or whatever, that's been viewed 160 million times, that's becoming more and more the norm. And that is driving traffic growth, and going forward we're looking even into like virtual reality, augmented reality, where you have like 360 videos and stuff like that, where you're really getting into very big amounts of data. So what you see on your networks, the amount of growth you see, this is the green line down there. This almost looks flat compared to the growth we see actually within our platform. So this, you see a lot of growth actually compared to what we have internally. This is nothing. So this is where the real growth is. That's within our data centers and between our data centers, machine to machine. It's like the calculation of the social graph and replication and stuff like that. So actually scaling our own platform is even more challenging than what you see. And that's mainly because of the very unique way all our content is user generated. So you actually have a very small amount of very popular data, like that Chewbacca lady or whatever. And then you have stuff that might only be viewed 5 times when you post your lunch and never seen again. So, well, what's important for us? Reliability is a really important thing. I mean, we had cases in the US where people called 911 when Facebook wasn't available. So people really see this as essential nowadays, which is great, but also scary to some extent from my point of view. So we're really looking into scaling the network that is on our own infrastructure, that is cooperating on submarine cables. We just announced, like with Microsoft, a transatlantic cable a while ago. And that's collaboration, like what Aftab was just talking about. Is the Open Compute project is a great example where we started like open sourcing our infrastructure to enable people to scale at the same time and getting economies of scale. And we start doing that in other areas as well, like the telecom infrastructure project, where we kind of try to do that same approach on the kind of last mile side. So how do we deliver content? This is really kind of different layers. So you have those data centers. This is where the Open Compute hardware sits. That's those wedge switches. That's Open Compute actual servers. Those are huge, multi-football-sized facilities, usually in pretty remote places in like Oregon or Texas or Sweden, where we have natural cooling close to the polar circle or 100% renewable power. So those are in areas where it makes sense to build a facility like that size. Those data centers never actually connect to the end user. Those data centers are really the origin. That's where all the stuff you post gets stored and never deleted. I mean, this is one of the things you got to really take into account here. We never delete anything. Every day there's insane amounts of data added to this store, and those all live in those data centers. So just seen yesterday, like the opening social, like everybody video filming the social thing. There was like 20 people with their phones. That all goes on there, and that never goes away. That will be there for eternity. Those data centers are connected to our backbone, and they connect to our POPs. So what we call a POP is literally that's where we interface with the world. That's where you see us. So a POP is in a carrier-neutral data center where there is connectivity. The nearest one to you, for most of you in this room here, would be in Singapore. And the POP is where all the TCP sessions from the end users terminate. So any session from the end user will terminate at the POP, which makes it closer to the end user, shorter TCP round trip, shorter TLS round trip for the encryption, and the POP then in the back end talks to the data center to get what it needs. It both caches static content in the POP, so there's very large caches there, and it terminates dynamic content that it then fetches from the data center in the background over its own session. Because of that, it's not that relevant for the user experience where the actual data center is. It's much more important where the POP is. And the POP is where we peer. This is where we interconnect with your networks, either over an IX, so pretty much all our POPs have connectivity to at least one IX. We have private peering, or via transit in some cases. And the third kind of pillar here is FNA. That's our cache solution. That's optional. We don't need that, but that's a possibility for you to get static content closer to your end user. A little bit more about it later. So what's our best practices for peering? Well, one of the most important things is PeeringDB. We have Aaron back there, who is a big contributor to that. PeeringDB, if you don't use it yet, you definitely should if you run a network. This is an open database where you actually list your connectivity. And quite literally, we cannot set up a session with you if you don't have an up-to-date PeeringDB entry, because our tool requires it. I cannot actually set up a session without it. So please get a PeeringDB entry and update it. The other thing is we really kind of try to stay ahead of the curve, so we try to upgrade early. So we typically aim to upgrade at 50%. I know in reality very few operators actually want to do that, but the idea here is really if we start at 50%, by the time it actually happens, we're probably at 70 or 80. So we really try to initiate that as early as possible. And we look at redundancy in multiple ways, both within the POP. So every one of our POPs has at least 2 edge routers. The bigger ones have more than that. So we'd like to connect to both of those routers in a POP if we peer with you, and we also will try, if possible, to connect to you in multiple POPs to really make sure this is available for you 100%. Just another quick thing here, we don't do giggy interfaces. This is a question we get quite often in this region, and unfortunately we don't even have any hardware that supports that anymore, so 10 gig is the smallest we can do, but we're fairly flexible to do that even at relatively low traffic levels. The cache The FNA, Facebook Network Appliance, is our offering to get closer to your end user, where we're not directly connecting to a POP, and that's really complementary to the connection in the POP. The cache can cache all static content. Static content, that's really the pictures, the videos you share. That's the by far largest percentage of the traffic. And that's a very wide range. That goes from like tiny profile pictures that there's lots of, those are not very well cacheable, to big videos which are very cacheable. So the overall efficiency is obviously a blend of that. And we typically achieve about 80% offload on that, which given that size is actually quite good, I would say. In some cases it's actually much higher than that, but that really depends on the market and the mix of pictures versus video and so on. I think we're really short on time, so I'm not going into too much detail. So the FNA, the smallest version, is four servers and one switch. We can do that in AC and DC power, and the minimum is 2 10 gig uplinks. We can do that up to a full rack with 100 gig uplink. The kind of some features we looked into that when we launched that is we use virtual IPs for all the services. This allows you to differentiate services and also zero rate in those countries where that is popular based on those IPs. Those of you who know me from my previous job know that was always a challenge. And we set a switch up as a layer 3 device. This is not because it actually does any dynamic routing. It doesn't. It's static. It's just to isolate the virtual IPs from you, so you don't have any MAC churn or anything. You really just get a static subnet for the cache. The cache fill for those caches happens from the peering where we have it. So this actually gives you a lot of control. This is not coming via your transit. If we peer with you, we can actually set where the cache fill is coming from, and also dynamically update that onto like backup locations. We do prefer v6 wherever we can. So all our internal stuff is on v6, and where the end user supports v6, we serve them via v6. But even if the end user is coming in via v4, we would still get the cache fill using v6, where the cache can get a v6 connectivity. So we really kind of prefer v6 wherever it's possible. Given in the interest of time, I think this is really it. Thanks a lot. If there is any questions, please let me know if you don't want to do the coffee break.
Thank you very much, Matt. I think we are a little bit running behind the time. So next tea break, and next session will be started in this room at 4 o'clock. Thank you very much.